So we'll start off with an easy one here. How many meters is 250 kilometers? I'm sure you can all do that if you take just a moment to write it out and actually show your work, please. And then I'm going to use my method to show you how it works. So how many of you did something like this, where you went 250 kilometers and you know logically that there's 1,000 meters in a kilometer, so you multiplied by 1,000 and you got 250,000 meters. Okay, a couple. The method that I use is I take my original quantity, 250 kilometers in this case. If it's just an individual quantity like this, then I put it over 1, just for my own, keep myself straight. If it's a quantity like kilometers per hour, then you would put 1 hour on the bottom, okay? But we'll do an example of that in the next one. And then I set up a ratio. Now I've got, when I taught grade 9 math, I called this top shelf, bottom shelf. So I've got a unit on the top shelf that I don't want. I don't want kilometers anymore. So I'm going to put kilometers on the bottom shelf. And then the unit that I want is meters. So I'm going to put that on the top shelf. So that's my first step, is I set up the ratio. Now I need to put in the numbers. I hate working with decimals. That's me personally. If someone in the other class loved decimals, I'd say go for it. You'll get the same answer. So I hate working with decimals, so I always take the bigger quantity, or the bigger unit, and I make it 1. So I go 1 kilometer, and then I say a smaller unit. Now, 1,000 meters is equal to 1 kilometer. So if I were to take 1,000 meters, keep up smartboard, 1,000 meters is equal to 1 kilometer. So if I were to substitute 1 kilometer in here, into the equation here, I would get 1 kilometer over 1 kilometer. What does that equal to? It's just 1. So if I multiply anything by 1, it doesn't do anything. So this is just a fancy way of saying 1. But it's getting rid of the units I don't want and getting me to the units that I do. So I just multiply this through now. So again, it's 250 times 1,000 gives me 250,000. And the units, kilometers cancels, so I have 1 on the top and I have 1 on the bottom. So kilometers cancel, and the units I'm left with are meters. Okay? That's a very basic example. I want to do a second one that's using slightly more complex units. So this will be this one right here. Now this is a unit conversion using currency, but the idea and the principles and the way you set up the problem are exactly the same. So I'd like you to try that one. So again, you may have your own system for doing this, but the way that I would approach this, I'd start with my quantity or my given value. So in this case, it's 100 Thai baht. That would be 100, and I'll just call it T for a variable. Now I'm going to put that over 1, just to make my life easier. And then it gives you some values. So it tells you that 100 Thai baht is equal to 2.44949 US dollars. So set up my ratio, my fraction at the on the next line here, and I want to get rid of the Thai. So I have it on top. I'll put it on the bottom, and then I'm going to convert to US dollars. And it tells me that 100 Thai baht is equal to that. So 100 Thai baht is equal to 2.444949 US dollars. Now if you want, you can do this one step at a time. You can multiply this through and you can figure out how many US dollars this is worth, and then go to the Canadian currency and convert US to Canadian. I like to do it all in one step. It just means you set up another ratio. So I've got US dollars on top. I don't want them, so I'm going to put it on the bottom. So US dollars on the bottom, and I want Canadian up top. And it tells you that 1 US dollar is worth 1.3, oh come on smartboard, 36936 Canadian. Obviously that exchange rate's a little bit old, but you get the idea. So now you just multiply through. So you go 100 times 2.44949 times 1.36936 divided by 1 times 100 times 1. I can't remember what the answer is. Someone work it out with a calculator. It's 3 point something. So you multiply all that through and you'll get 3.35. Make sure you include your units, Canadian. So 100 Thai baht is worth 3.35 Canadian. Okay, our next example actually makes use of some of the units we'll see in physics. So we have a speed, and it's in feet per second, and it asks you to convert this to kilometers per hour. Now, anytime we use imperial measurements, I will give you the ratio. So I'm just going to write that on the board here. So 2.3 feet per second, that's our measured unit that we're starting with. You can only eliminate one of these units at a time. So which one do you want to start with, the feet or the seconds? Feet. All right, let's get rid of feet. So what am I going to do? What unit am I going to put on the bottom here?
Feet.
Feet. I don't want feet. And what units do I have a number or ratio for that I can put on the top?
Meters.
Meters. Not the unit that we want to get to, but it takes us to where we want to go. So we put meters up top. What's the numbers I put in?
3.8.
Yeah. 1 meter is 3.28 feet. Okay? I'm going to do this all in one long shot. If you wanted to do it right here, it would tell you how many, if you multiply that through, feet would cancel and you'd get however many meters per second. Okay? That's not what we want. We want kilometers per hour. So I'm going to continue along. Can I get from meters to kilometers fairly easily? Yeah. Where am I going to put meters?
Bottom.
Bottom. Where am I going to put kilometers? Not really much of an option there. Okay, which one's the bigger one? Kilometers is the bigger one. So Mr. Villa hates working with decimals, so I'm going to put a 1 there, and I know that it's 1,000 meters per kilometer. Okay? So that will get me to my length unit. It will get me to the kilometers. But this will only tell me how many kilometers per second. That's not the unit they want. They want us to be kilometers per hour. So I need to keep going. So now what am I trying to get rid of? Seconds. Where is seconds? It's on the bottom over here, right? So I want to put it on top. And what am I going to put on the bottom?
Seconds.
It's a unit of time, so I want it to be hours. Now you can, if you want, girls, you can go one step at a time and you could go to minutes, and then you could go from minutes to hours. Because sometimes you got to go from seconds to years. So if you want to set up intermediate ratios in between, by all means do that. But I think we can all fairly quickly figure out that 1 hour is 3,600 seconds. 60 seconds in a minute, 60 minutes in an hour, 3,060 seconds in an hour. So now, when you multiply all this through, hold on, feet will cancel with feet, meters will cancel with meters, and I'm left with kilometers as my my unit for length. Seconds will cancel with seconds. I'm left with hours on the bottom as my unit of time. So then, multiply it all through, 2.3 times 1 times 1 times 3,600, divided by 3.28 times 1,000. Make sure you do your order of operations properly in your calculator, because you don't want to go all of that divided by 3.28 and then multiply it by 1,000, because then you'll get the wrong answer. Yeah. So 2.5, my units are kilometers per hour. Or you can rewrite it as 2.5 kilometers per hour. All right? So that's the examples that we're going to do in class right now. There are a couple of others in here. This is just a silly one I made up. If you want to attempt that, you can go back and look at the video and work that one out. And then there's another one here. These are actual old ancient Greek measurements that they used. Now, why is this so important? Well, this is one of the most extreme examples I could find. Mars Climate Orbiter was launched in December 1998. Its purpose was to monitor the Martian climate and serve as a communications relay point for other Mars missions. Everything was going super duper. They launched the spaceship. It was traveling all the way to Mars. It took a couple of years. Got to Mars. Was supposed to do a little maneuver so it would end up in orbit around the planet. And when it did that maneuver, it crashed. $200 million and lots and lots and lots of man hours wasted. The orbiter did absolutely nothing. You want to know why? What went wrong? Well, there were two teams working on this. One team in California and one team in Colorado. One team was working in metric, so meters and seconds and kilograms. And the other one was working in imperial, so miles and pounds. And they didn't bother to tell each other, and nobody checked the math. This is NASA. Nobody bothered to check the math, and the mission was lost. So I'm guessing somebody got fired over that one.